Okay. Hello, everyone. Thanks for joining today for the live webinar. And also to those of you who are watching the recording later, we just appreciate all you guys showing up today and hearing what we have to say. My name is Brian Stout. I am the co-founder and chief product officer at iVALT. So just a real quick history. Baldev Krishan and I started this company 7 years ago. And our goal was to basically address the problem of who is the human at the end point in any interaction online. And the problem at the time, and it remains a huge problem, is that credentials doesn't tell you that. And stolen credentials is an enormous problem. And I'll get into a little bit more of that in a few minutes. And over time, we kind of went down the path of biometrics, adding biometrics is great, but that's not enough either because biometrics is going to be a moving target and hackers and AI and other things are going to make biometrics compromised as well. And so we went down the path of let's create five factors. And the five factors that we chose were the biometrics from your mobile phone, which everyone uses, and then create a public-private key pair, a PKI relationship between the mobile phone and our authentication server, which creates a cryptographic link between the mobile phone and the biometrics and our authentication server. And then while we're at it, capture GPS location, time, and then verify that the source of the request for identity or for human authority came from a trusted source. So we sort of started, if you want to think of it in a kind of interesting way, is we thought we're going to create a better I for IAM because I was basically credentials, and we're looking at these five factors. And really, it was kind of an uphill struggle because everything's embedded. Everybody thinks that everything that's there is adequate, even though there's $8 trillion a year in losses based on stolen credentials. But the tipping point is AI, and AI is not session based. It doesn't work the same way as IAM sessions and tokens, and it requires a completely different approach to verifying agentic AI identity. And so, what we're going to talk about today is provable human authority, which is kind of the category that we are in, and we're going to show how we can do this with 10 lines of code. So this is very simple to implement, and it's one-click user experience. And so that's the approach. Those are the things that we're going to discuss today. So first of all, this is sort of my elephant in the corner or elephant in the room slide, is what's the truth about identity? And it's really the biggest gap in cybersecurity. And we're seeing more and more of this in the press. I think you guys have all seen more and more things are coming out from all the big companies that it really all boils down to identity. And if you know the human being at the endpoint, it solves a whole host of problems in cybersecurity and probably could set us on a much better path. And so this is really because identity relies on static credentials that can be stolen, obviously. And so 80 to 90% of all cyber threats start with stolen credentials. So things like the MGM attack of about a year and a half ago or 2 years ago was basically stolen credentials. It was done in a way that they called a help desk, and they were able to convince a help desk worker that they were somebody important that had rights, and were able to get passwords changed. And then once you have access to the right person's credentials, you can do a lot of damage. So you can get access to IT systems and download and exfiltrate data. So that's the first point: is that static credentials can be stolen. The second is identity is not the same as authority. So the fact that I know a person has valid credentials that comes in the front door doesn't mean I really want to give them authority to just do anything. And so depending on whose identity is stolen, there's different levels of authority that are basically assumed or inherited from the credentials at the front door. And this is the problem. So if you come in the door with valid credentials, you can basically do whatever the person could do that you stole the credentials from. And then RBAC and ABAC, role-based access control and attribute-based access control, and privileged access management all limit access. So they control the access down to more specificity on what people can get access to based on who they are. But it still doesn't prove that you have the right human at the endpoint. It's still just a set of credentials. And even step-up authority can be hacked. It's going to be something like maybe a IP address, which is very difficult to do, or time, et cetera, which we capture that anyway as part of identity. So there's a pieces of this that we can do just from the identity itself. And the last of all, a gap is that authority is blindly assumed after authentication. So once you log in, you blindly are given authority. And what companies and enterprises are realizing is you're inheriting all of the identity risks that have been a problem for 20, 30 years. And so the $8 trillion losses are the starting point with AI. So that's a huge problem for AI, and it's causing a lot of trepidation in the AI market. So assumed authority is really already a problem. So the inherited risk enables catastrophic actions. So if you look at the way a standard login takes place is credentials. If you have valid credentials, your authority is assumed and you inherit the risk, or the company inherits the risk, and then critical actions take place. Well, if somebody comes in who is a bad actor, and this could be a human or it could be a rogue agent, comes in and goes to the critical actions, they can create a breach, and that this happens on an increasing basis. And as I mentioned, is $8 trillion a year in losses in this way, and not directly by getting access to IAM, but also just stealing those credentials, putting in malware, creating all kinds of operational risks, etc. Okay, so the bigger problem is that AI amplifies this risk at machine speed. So we're all going to have many, many agents. We're going to have access to many, many agents. As AI continues to go out in the marketplace, this is going to become a bigger and bigger problem. And so consequently, this is where a lot of fear and trepidation is coming. And so what we do is we provide an intervention point, if you will, in between the access and the critical actions. And we call this provable human authority. And you can put this anywhere before a critical action. And this can work across the board for everything. And I'll show you that in just a second. And so assumed authority and inherited identity risk, just are unsustainable. So the way we're going right now just is not survivable into an AI era. And so that's what we're addressing with what we have. So the word existential is always being used a lot, but AI actually makes assumed authority existential because the companies become at so much risk based on rogue AI agents and hackers, etc. And this is causing the enterprises themselves, the C-suite, IT managers, etc., to not trust autonomous AI. And this is understandable and is actually appropriate until there's a way to protect AI execution in a way that the right human being is implementing that action and it's not coming from a bad actor. And so the problem really, as these folks are looking at it, is machine speed execution is a point of no return. It's like lighting a fuse. And so once you light it, you really can't come back from it. So AI governance, and any of you who went to the RSA conference, it was all about AI governance. AI governance is great. AI governance provides a lot of capabilities in being able to manage agents, control the actions that agents can do, etc. But it doesn't prove who the human is behind the actual actions that the agents are being set to do. And so it creates the governance layer, but it adds friction while doing good things, but it doesn't create the provable human control that's necessary. And then proof of authority. This is really an interesting point here that if you are going to provide authority to take action for an AI agent, it has to be real time and it has to be continuous. It has to be whenever is necessary, deemed by the management of the company or the IT department. They're going to say, and when we get to these certain points in AI execution, we need to make sure that somebody responsible for this action is actually giving approval, but also that action can be logged and we know who did it and when they did it. So there's accountability as well as proof of authority and approval. And it's contextually relevant. So every AI workflow, every time it runs, it's going to be, or when it's running continuously, it changes contextually, depending on variables in the environment. And so those contextual variables may change who has to actually authenticate. So those are decisions that are made by the enterprise, and then what we can do is verify the correct human depending on who is deemed to be the responsible party and the person authorized to make that decision. And so if you can prove human authority, it has to be done at the moment of highest risk. And that's what we do at execution. So what you don't do is log in, give someone access, assume their authority, and then at the end of some AI delegation chain, you have an agent doing something that it wasn't authorized to do. Okay, so proven human authority, which is what we provide, is really cryptographically bound human device and context. So the idea is we capture biometrics, and this is on a mobile phone, which verifies the human, and then we use that in combination with the device PKI so that we can do a cryptographic relationship between the device and the biometrics to the authentication server so we can prove the human. So the first two prove the responsible human. And then the context is something we can capture that can be used in the authentication to verify that it was the right person at the right time for the right action as deemed appropriate by the organization. And so this changes everything because we're not assuming authority, we're not inheriting trust. We're basically saying that's fine. Let's just leave that alone because it's a big lift to change out all the username and password systems in the world. Let's just implement something that's an overlay that says, hey, when you get to these actions, we got to go a little bit higher and more, go a little deeper in determining that the right human being is at the end point. And that's very, very difficult to implement with existing systems. So we are an overlay. However, we provide access to existing systems, and we are compatible with everything. We have SAML federation. We can do a whole lot of things where we can integrate ourselves into existing ecosystems. Okay, so this does work with all existing infrastructure. And as I mentioned, it's a simple overlay architecture. And so the way this looks is every enterprise out there has some of these, if not all of these systems already in place, and they have their own identity and governance, etc. So one of the things at the beginning, Baldev and I, we were like, we can't, this has to be very, very simple. And we set a very high bar of it has to be one-click user experience, which I'll show you that in a second. But it also has to fit with everything that already exists out there. We can't come in and replace IAM, for example. It has to be compatible with all these other systems that are out there and just provide this strength of authority verification that is missing. And that's why we have $8 trillion worth of losses. And then in AI, it's going to be exponentially higher, and we can protect that with the way we take this. So there are no changes that are required. So we just leave the existing platforms to authenticate identity, and that's what they do now. So identity being credentials primarily, okay? And then what we do is there, when you get to these critical execution points, checkpoints as we call them, you have the ability to do human authority enforcement through our platform, where we verify it's the correct human at the endpoint. And this is a one-click experience for the person. That pings their mobile phone, they show their face, their biometrics, unlock the cryptographic relationship and the GPS location and time. And then those things can verify the human being at the endpoint in less time than it takes to use two-factor authentication for sure, but it's in seconds. You can verify that you have the right human before you do something that's potentially very dangerous. And so a key point here is that identity grants access. So we've had identity for many, many years. It really just grants access. The authority approach we are talking about gates the execution. Is it the right person doing the execution, which is where all the damage takes place? So the fact that someone gets in the front door is bad, but the fact is, most companies, cybersecurity companies, have been putting bigger locks on the front doors, and the hackers keep hacking them. They keep breaking in, picking locks. That's not the problem. The problem is once they get in, they execute things that are damaged, and they exfiltrate data, they get access to operational systems, etc. So you've got to stop and gate the execution to really protect the infrastructure. And this is how you actually fix the old problems, but also have the solution for the AI era going forward. Okay, so human authority checkpoints is really the decisions that are made by the enterprise on what's really important. What do we need to protect? And so we call this enforcement. And the idea here is let's make this really simple. Again, this was back to Baldell, and my initial positioning was this has got to be super simple because nobody's going to adopt this if we just add more friction and make it more difficult, more complex, more costly, etc. This had to be really drop dead simple. And so we call this drop-in action hooks, and this is really on the IAM side. So if you have the best example I always use is Salesforce.com. Salesforce.com has the ability to put hooks in for either step-up authentication, which is used, but we could use that capability to be able to step up and say, hey, you know what, before we execute this download of the entire database of customers, how about we verify this is actually Brian at the other end as opposed to somebody stole his credentials? And so it's a one-step, one-click experience before someone can export data like that, which will stop the data exfiltration by the current methods. And then on the AI side, it's a drop-in skills. So within Agentic AI, we're talking about a skill that basically is less than 10 lines of code or around 10 lines of code that can be used to just basically say, hey, before you take this action, the agent has to execute a skill which says, calls our API, verifies the right human, and in the Agentic workflow, the person who is responsible at that point in time and at that in that time and in that location and for a particular application with a set of variables around it of which we don't care that those are set by the enterprise. We need to execute this skill and verify we have the right human making that decision and authorizing that. And this is all done in real time. And as I mentioned, it's with context. So this is not a static let's just ping this person or human in the loop, if you will. We are sort of human in the loop on steroids because it's cryptographic and it's dynamic and it's done with context. So the person who gets pinged may be different depending on the context and the location, etc. So that's the idea of what we do. And we can do this across IAM to fix the existing problems and then do it for AI, which is the real coming problem, which is creating friction in the AI adoption lifecycle. And so continuous human authority during execution is really what we're doing. And it's at the critical points of execution as defined by the enterprise in terms of what their risk profile looks like. And it can be fully controlled by IT. We don't have any say in any of that. So we're not dictating governance or anything like that. We're just saying drop this code in at the places that you need to get verification and then put whatever parameters around who has to be the person that authenticates. Okay, so 10 lines of code. Everybody, it's always intriguing to see what does that look like. Well, 10 lines of code is really pretty simple. At the critical points of execution, and this could be either the AI agents for a skill, which in Agentic AI, you can create skills for agents, or in IAM or SSO apps, which are action hooks before a critical action like an export I mentioned before. So very simple JavaScript. It calls our API, and it's very simple. And it could be much more complicated than this based on some other variables that are part of the agentic workflow. But for the sake of just showing what we have, this is kind of the basics of what this is. It's pretty simple. So you drop this in and set up who is the person that receives this. It goes to iVALT. We do provable human authority on a mobile phone. It pings their phone. They hold it to their face, mobile biometrics. verifies the cryptographic relationship between the biometrics and the device ID, device PKI, I should say, and it captures the context if that's interesting for the decisions. And it's a one-click user experience. So this is much easier than even two-factor authentication. So that was one of our criteria at the beginning here. And so what it comes back is, oh, okay, it really is Brian. Go ahead and do whatever was required there. So what we have is 10 lines of code, which translates into one-click user experience. And what you have is provable human authority. And you have not only the human that approved it, you know that you got the right human approving it, you have an audit trail, which is accountability, which doesn't exist really in very strong ways. This is not token extensions. This is not let's take a token, create special tokens. It isn't any of that. This is just at a point in time, you drop in the software, you verify the person in real time. It doesn't have to be integrated into the workflows in the same way that the token extension model is. This is much simpler than that. Okay, so deployed use cases. So how we started to use this stuff. So first of all, we have a company, a partner named BastionX, and they are doing AI ticketing for customer service. So access to accounts, sensitive actions like changing passwords, et cetera, things that a help desk might do, or looking up orders, or giving refunds, all that sort of stuff. And what this does is it stops social engineering and AI deepfakes. So if you think about this, there's two sides to a customer service interaction. There's the KYC, which is the know your customer, which we can take our SDK and embed it in an existing app for anybody. So they can be a push notification to the customer. They verify themselves. You know where they are. You know that they were cryptographically identified. This is stronger than any KYC out there. You're certainly not asking them 30 questions in order to get access to their accounts. And on the other side of it, there can be a verification of the customer service agent or the person, the representative, at the same time so that the customer is comfortable that they didn't get a phone call. If it's an outgoing phone call from the call center, they can be comfortable that this is not a scam call. It's not somebody pretending to be the new bank representative or something like that. So that's one action here, and that can be integrated with the AI system there. Second of all is AI governance. Well, I just said AI governance is a great thing. What you need is authority proofing within AI governance. And so we're working with a company, this is under NDA, so I'm not going to share the name here, but it's dynamic privileged access. As I mentioned before, the identity proofing or the authority proofing is dynamic. It depends on the time, the place, what's actually being done, the thresholds on risk, et cetera, et cetera. So if you're able to identify the human being, this simplifies the governance a lot because you're not trying to asymptotically approach the risk. You actually know you have the human. So it's not about create more policies to try to make sure you don't get the wrong human. It's about knowing you have the right human from the beginning, which makes this a lot easier. And there also is the protection of IP in real time. If information is being shared, that can be protected by the same mechanism. And we actually have a product, I'm not going to get into that here, but we have a product called DocuID, which basically embeds your identity, say your mobile phone or your email address, into a document, and your identity is required to decrypt that document. And so if I send Baldev a document, and he receives it. He gets a link to a cloud infrastructure. He's the only human on the face of the earth that can open that document because it requires his identity to be verified cryptographically before he can open the document and decrypt the document. So that's another thing we can do within the governance. And this provides for safer deployment and certainly for scaling. And scaling has another whole set of dimensions, and I'll mention this at the very end here is what do you do if you're outside the perimeters of the enterprise? And so AI identity can't just be AI identity within the four walls of the company, the enterprise. It has to persist across a number of different ecosystems, different companies, supply chains, uh, access to information from a variety of sources. And the human has to be trusted in those places. And so what we have is the ability to do the cryptographic matching between the agent and the human, and what authority the human has actually to get involved in ecosystems and beyond. So that's the second use case. And then the third use case is OpenClaw. We have actually integrated skills into OpenClaw for machine speed workflow protection. Okay, and then this is the universal enforcement layer for human and AI execution. Okay, last of all, just OpenClaw. I actually built this myself. I haven't been a coder. I haven't coded in 45 years. Telegram, we did it on my local terminal server, AI gateway. We used OpenAI, and it actually works. It recognizes a protected action and implements iVALT from a skill. Okay, so the takeaways are that we control risk where it matters most, which is at execution. We prove authority before every critical action. There's no platform changes. This works immediately with enterprise. This is hours of deployment, not days, weeks, months. Can be implemented immediately. We can do SAML federation, but we don't have to. It's deployable today across everything, and it ends the assumed authority and it enables trusted AI execution. That's my presentation. If you want to request a live demo or an enterprise evaluation access, we can give that to you. And then the next topic I'd love to talk to people about is how do you trust delegated authority across autonomous AI ecosystems? So this goes beyond the enterprise into the broader world deployment of AI. Okay, that's what we have. And thank you all again for participating. If you have questions or anything, my contact information is here. You can also contact us on the QR code here or at info@ivault.com. Thank you so much.